So next we are going to discuss about evidences for the E2 mechanism, isotope effects. So the second order elimination shows a large hydrogen isotope effect. So what is mean by isotope effect? So different isotope of the same element have by definition the same electronic configuration and hence similar chemical properties. So this similarity is the basis of the isotopic tracer technique. So one isotope does pretty much what another will do, but from its radioactivity or unusual mass can be traced through a chemical sequence. So different isotopes have different masses, and because of this their chemical properties are not identical. The same reaction can occur but at somewhat different rates. So change in rate brought about by replacing an hydrogen atom by its isotope deuterium. So CD bond is stronger than a CH bond. So usually expressed as KH by KD. So if KH by KD is equal to about 7, so this means that the isotopically labeled bond is being broken in the rate determining step, indicating that the reaction is E2. So ഇവിടെ നമ്മൾ ഹൈഡ്രജന് പകരം ഹൈഡ്രജൻ്റെ തന്നെ ഐസോട്ടോപ്പ് ആയിട്ടുള്ള ഡ്യൂട്ടീരിയം നമ്മൾ റീപ്ലേസ് ചെയ്യാണ്. ഓക്കെ, സോ ഡ്യൂട്ടീരിയം കൊടുക്കുന്ന സമയത്ത് എന്ത് സംഭവിക്കും? CH ബോണ്ടിന് പകരം അവിടെ CD ബോണ്ട് ഫോം ചെയ്യും. ഓക്കെ, കാർബൺ ഡ്യൂട്ടീരിയം ബോണ്ട് ഫോർമേഷൻ നടക്കും. സോ യൂഷ്വലി എന്ത് സംഭവിക്കും? കാർബൺ ഡ്യൂട്ടീരിയം ബോണ്ട് എന്ന് വെച്ചാൽ അത് CH ബോണ്ടിനേക്കാളും സ്ട്രോങ് ആയിരിക്കും. സോ അതുകൊണ്ട് തന്നെ CD ബോണ്ട് ബ്രേക്ക് ചെയ്യാനുള്ളത് കുറച്ചും കൂടി പ്രയാസമായിരിക്കും. ഓക്കെ, സോ CD ബോണ്ട് ഈസ് സ്ട്രോങ്ങർ ദാൻ എ CH ബോണ്ട്. സോ ഇഫ് KH by KD, KH that is the kinetic of first reaction, that is by using hydrogen, and KD is the rate constant for the reaction that proceeds with deuterium. So if KH by KD is equal to 7, this means that the isotopically labeled bond is being broken in the rate determining step, indicating that the reaction is E2. So as you learn all these mechanisms of substitution and elimination, you should appreciate how we have come to know how the mechanisms occur. So one way we to study a mechanism is to see how replacing a hydrogen atom with its isotope deuterium affect the rate of a reaction. If the rate is affected, it is likely that particular hydrogen atom is involved in the rate determining step. So hydrogen is called H1, that is called hydrogen. It is abbreviated as H, and H2 that is called deuterium, abbreviated as D. So deuterium has the same chemical reactivity as hydrogen. So consider the following reaction where an alkyl halide undergoes elimination with a strong base, which you already known is called the E2 reaction. So alkyl halide react in presence of a base. We can get a alkene and a protonated base plus leaving group. Here the leaving group is Br minus. So when we replace the beta hydrogen with deuteriums, the reaction occurs at a slower rate. So this is called the kinetic isotope effect, because there is a difference in mass of hydrogen and deuterium. So that's why CD bonds are more stronger than CH bond. So difficult to break the CD bonds. So that's why the reaction occurs at a slower rate, and this is called the kinetic isotope effect. So നമ്മൾ റീപ്ലേസ് ചെയ്യുന്ന ഐസോട്ടോപ്പിനനുസരിച്ചിട്ട് റിയാക്ഷൻ്റെ റേറ്റ് വ്യത്യാസപ്പെടാം. അതിനെയാണ് നമ്മൾ കൈനറ്റിക് ഐസോട്ടോപ്പിക് ഇഫക്ട്സ് എന്ന് പറയുക. ഓക്കെ, So a difference in rate due to a difference in the isotope present in the reaction system, that is called as isotope effect. So if a particular atom is less tightly bound in the transition state of a reaction than in the reactant, the reaction involving the heavier isotope of that atom will go more slowly. So the hydrogen isotope have the greatest proportional differences in mass with deuterium. Deuterium is twice as heavy as protium and tritium. So is 3 times as heavy. As a result, hydrogen isotope effects are the biggest, the easiest to measure. And because of the special importance of hydrogen in organic chemistry, isotope effect due to the breaking of a bond to the isotopic atom are called primary isotope effect.